All right, I wanted to go over the solutions to this triangle congruence worksheet here. So I'm going to kind of quickly go through it. Okay, so for these first problems, we're supposed to identify whether there's enough information to state that we have a triangle congruence, also including anything else we can figure out from a picture. We'll get into that in a minute. Second thing is finish the congruence statement. So we need to finish naming the other triangle. And then what is our reason? By reason, I mean what triangle congruence theorem are we using? So I'm going to go ahead and start doing these. So first problem here, we have these two triangles here, SRU and this other one. And first thing I notice about them is they do have a shared side, which I do want to mark. Once I do that, we have 1, 2, 3 side pairs. So these are congruent. And the triangle congruence reason we're using is SSS, side, side, side. And then we want to go ahead and name our second triangle. So we have triangle SRU. SR would correspond with ST in the other one. So this is going to be STU for this other triangle. And that's it. That's all we got to do. We're going to go ahead and go through these next few pretty quick. All right. Second one, here we have our two triangles. We got a triangle GIF, GIH. Are they congruent? So based on the picture, the only thing that we can mark here is they do have a shared side. But luckily for us, that's enough. We have one triangle or one angle congruence, another angle congruence, and then a side. So these are going to be congruent by AAS. This is AAS because the side that's congruent is not in between the two angles. It's a non-included side. But that is one of our shortcuts. And then finishing up this statement, we have triangle GIF. Angle G goes with angle G in the other one. I and I go together, and H. So GIH is the proper name for this triangle here on the right. Okay, keep moving forward. Oops, did I skip one? No, I did not. Okay, so here we have two triangles. They are right triangles, which is going to be important for this one. We have one congruent side, another congruent side, and a pair of congruent angles. So based on the arrangement of these, this is side-side angle. The angle is not included, so SSA. SSA is not a congruence, right? So I can't use that. But luckily for us, these are right angles, and the hypotenuses are congruent, and a leg is congruent. So this is going to be hypotenuse leg. So we got a yes by hypotenuse leg. Then we want to finish this triangle congruence. BCA would be EFD for our other naming. Remember, we have to name them in a corresponding order. Okay. Next one here, we do have some vertical angles we need to mark in the middle. So these are vertical angles. And once we do that, we have two angle pairs and a side pair in between. These are going to be congruent by ASA. So yes, ASA. And we have triangle CAB. So that's going to go to CDE. Easy enough. Go ahead and clear that off. Move forward. All right, so now we have, on this one, we have a shared side down the middle. We have a pair of congruent sides, a shared side, and then the angles in between those. So this is SAS. So these are congruent by SAS. And for our naming, we're going TUS. So that's going to go RUS for the other naming. RU corresponds to TU. That's how I know to start that way. Okay, clear. Next. All right, now this one here, we have shared side, so mark that. So we have a pair of congruent sides and another pair of congruent sides, shared side, and some congruent angles. But these angles are non-included, so this is SSA. There is a temptation here, since these would be parallel to each other because we have some alternate interior angles, but that's not going to be enough here. to give me any other amounts of information. A lot of people would be inclined to say that these angles here are congruent, but that's actually not true because they would not be on the known parallel lines. So since this is SSA, that's not a triangle congruence. So we have a no, and there is just not enough info. I'm not saying they aren't congruent because they certainly look like they are, but there is not enough info right now to state a triangle congruence. All right. Now for these next slides, we're going to be completing some two-column proofs with missing statements and reasons. All right, let's take a look at this problem. We have triangles here and here. We're trying to prove triangle ACD and BCD. So ACD is this one. I'll go ahead and outline that real quick. ACD. That one, and then the other triangle, BCD. BCD. Cool. Next, what do we know is congruent? So we are given that AC and BC are congruent, and D is a midpoint. So those are obviously going to be our two given statements. So I can go ahead and fill those out. AC congruent to BC, and D is midpoint of AB. So those are obviously given. They're right here, given. Then in this proof, it says we are going to be using the definition of midpoint. Well, if that's the midpoint, that means these two halves are equal. So we can say that AD is congruent to BD. Could name those differently, but that's the way I chose here. Next thing I see is DC is congruent to itself. Anytime something's congruent to itself, we're making use of what's called the reflexive property. Reflexive property of congruence, because we're talking about congruent, works for equal as well. And then we have a triangle congruent statement. So we need to figure out what theorem was used. In this case, it looks like it was side, 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 because we have three congruent side pairs. All right, next. All right, this one's a little tricky because we do need to figure out what triangles we're trying to prove are congruent. So we're trying to prove DEA. We're trying to prove this triangle here is congruent to FEC. FEC. Okay, so those are the two triangles we're trying to prove that are congruent. We have given to us that AC and DF bisect each other. So bisect means to cut exactly in half. So ACDF. So both of these segments are cut in half. Great. This is going to be my given. So AC and DF bisect each other. All right. E is the midpoint of AC and DF. Okay, so they're saying this is the midpoint. Yeah, that's right, because they're cutting each other in half, so that has to be the middle. And that's using the definition of a bisector. Okay. And then these next two are the same reason. So I think it's going to be the markings that I have here. So I made these markings. I do need to make them as statements. So I'll go ahead and do it in the order of this. So I'll say AE is congruent to CE. And that's true, right? That's because of midpoint or bisecting. I'm going to say it's the definition of midpoint. And we also have that DE and FE are congruent. DE and FE are congruent. And vertical angles theorem. So we're using the vertical angles theorem. The only vertical angles I see are right here across from each other. I do want to use 3 letters for these. So I'll call this one here angle DEA. Angle DEA. Follow the letters that makes the angle. And then I'm going to call this other one FEC. So making that angle FEC. Remember, when we're using 3 letters, the middle letter has to be the vertex, and if you say the letters and kind of trace the angle, they do need to match one another. All right, and then a triangle congruence, we need to figure out what theorem. Here I have two sides and an included angle. Same thing over here, so that is a triangle congruence. All right, and that's it. We have, I believe, one more. So let's go ahead and clear this and move on. All right, so for this last one, it's going to be a CPCTC proof. So that means corresponding parts of congruent triangles. We are given that PR bisects, like I said, PR is a line, so PR is this line, bisects two angles, angle QPS, so QPS, that's this one. So that angle got cut in half into 2 equal parts. And angle QRS, okay, so QRS. So this one over here also got cut in half. Okay, makes sense. That's the only options in terms of what it could have bisected, but just being clear. I'm going to give these some numbers for easily referencing them. That way I don't have to use 3-letter naming. I can just number them real quick. Okay, prove that PQ is congruent to PS. So these are the corresponding parts. Corresponding parts. They are here and here. I don't know they're congruent yet. I'm trying to prove that, so I don't want to mark that. Okay, what else do we know about this picture? The only thing I see is a shared side. We have 2 triangles with a shared side. So remember, to do a CPCTC proof, you have to prove that we have congruent triangles. So I'm going to prove the triangle on top is congruent to triangle on the bottom, and then use CPCTC to say that these 2 parts, which correspond to one another, would have to be congruent. There we go. First one is our given. Angle QPR is congruent to SPR. That's because we have a bisector, so that is the definition of, that's because PR cuts it in half, so definition of angle bisector. You could also just say definition of bisect, it's fine too, because to bisect something means to cut it into 2 equal parts. Then we use definition of bisector again. So that was one of our angle pairs, so this other angle pair is the other one. I'm going to use the numbers that I had to talk about these. So these ones are for angle 3 and 4, because we've already done angle. These are really angle 1 and angle 2 in my picture. And those are the 2 angles that we had. Reflexive property of congruence, that is our shared side, that PR is congruent to itself. These are a little bit lined up funny. I guess 4 and 4. Yeah, reflexive property. So PR is congruent to itself, reflexive property. And then angle, side, angle, triangle congruence. Angle, side, angle, angle, side, angle. Yeah, that works. So I need some names for these 2 triangles, and I'm just going to go PQR. P corresponds with P, S, Q, so P, S, R. That's this one here. And it is angle, side, angle. And then once the triangles are congruent, that means that these parts that are corresponding here and here have to be congruent. So PQ, congruent, PS, and we use CPCTC. That's it. And that's the whole worksheet. That's all the answers, guys. See you in class. Have a good weekend.